So you can also look at prograde fronts. And so prograde fronts are the ones which have heavier water near the coast. Okay? And because of the adjustment, because you have a pressure gradient that creates an adjustment, you actually again create a current which is illustrated here. The forces involved: pressure gradient force, Coriolis force, and the sloping sea surfaces. So you essentially again get a flow which tends to run parallel to the coast, but in this case the current interacts with the seafloor and you get a bottom Ekman layer, and you get some, we call it Ekman drainage. Some of the dense water actually tends to move downslope. Okay, and this is one example of prograde fronts in the coastal ocean. And I want to also show you a real example on the next two slides. There is actually an outflow of dense water from Spencer Gulf happening in late winter each year. So winter time, late winter, an outflow of heavy water flowing near the bottom. And historically, this outflow has been called Bonaparte's Tongue. And there's a sketch of this tongue. Okay. And how it is created, we come back to the regional, to the inverse estuaries later on and explaining it in more detail. But essentially, it's a very cold and hypersaline water. And that's what creates this density excess, creates the outflow. It tends to move along the shelf, okay, parallel to the coast, but it's the interaction with the seafloor that leads to a different flow path. Okay, so it tends to be more offshore. Some famous measurements of this outflow. This is from Jeff Lennon and et al. In 1987 in Nature publication. And you can see the contours of salinity. These are salinity contours. You can see where we are, Spencer Gulf. Okay, Spencer Gulf, Kangaroo Island. You can see the York Peninsula. Adelaide is up here. And the salinity of near the bottom. Okay, near the bottom salinity. And you can see values here. It's not very clear, but 37, 36. It's all hypersaline compared to ocean values. What are the values of salinity in the open ocean? Oh, 34, 35, something like that. This is hypersaline, and you can see the movement of that water and ending up at around 200 meters or so. It's actually similar to the outflow from the Mediterranean Sea, from the Eurafrican Mediterranean Sea, in terms of the driving, and also, but it doesn't end up very deep here. So the water is not so heavy that it sinks below 200 meters. Okay, gravity-driven flow or density-driven flow in the coastal oceans. One example, and indeed you can see a front. Look at the front. Horizontal change in density. There's a front all here along that western side. You can see a frontal. This one is the main frontal current. By the way, it also produces eddies, but the eddies are not resolved in these observations here. They have scales of about something like 5 kilometers or so, horizontal scales. You know, you have to do very fine observations in order to resolve these eddies. Okay? They're actually called spaghettis for this area. SP, Spencer Gulf, eddies, spaghettis.